Solar PV systems are traditionally designed to disconnect and remain offline for 5 minutes when tripped by loss of grid voltage. However, traditional solar systems are not equipped with the intelligence to differentiate between a complete loss of grid voltage versus a brief temporary hiccup in grid voltage. As the penetration of solar increases, this can cause adverse conditions on the electric grid that negatively impact both utilities and their customers. A real-life scenario where a utility distribution feeder experiences a loss of solar generation and the resultant destabilization of voltage levels on the distribution feeder due to a transient event is demonstrated as follows. We are in a neighborhood on a feeder with a very high penetration of solar PV, several miles from the utility station. It's a hot day, and air conditioning units are running full blast, so load is high on the electric utilities circuits. A tree branch falls on the power lines, shorting the wires together, but only for a very brief time before it falls to the ground. The power lines are not damaged and the power to the homes in the area is not significantly impacted. However, the transient event causes a drop in voltage that triggers the solar systems to suddenly turn off for 5 full minutes. When the solar turns off, the net load on the distribution feeder jumps to a higher level because of the loss of solar generation, and thus, the feeder experiences a quick drop in voltage level. Traditional utility equipment often does not have time to react, so consumers are affected. This drop in voltage may cause flickering lights, low voltage, and power quality problems for consumers. Voltage drops and variations may cause problems with consumer equipment, causing failures in microprocessor-controlled devices and other equipment. Failed equipment costs consumers money, resulting in complaints to utilities and utility regulators. For utility-owned solar, the utility company has just lost 5 minutes of generation from the solar generators. Over time, if such conditions persist, the local utility may feel the need to limit the amount of solar that can be connected into their grid. With voltage ride-through technology integrated into the smart solar solutions, the intelligent solar generators continue to generate electricity immediately following a transient event. Households will not experience as much flicker or power quality problems, and utilities will not experience as much demand variability on their generation systems. And the utility is not forced to limit the amount of solar on their grid because of solar system dropouts. In cases where there is a prolonged grid issue or outage, for example, a falling tree permanently shorts the wires until a utility lineman can repair the problem, the intelligent voltage ride-through feature will ensure, for safety reasons, that the solar will automatically turn off after a more permanent fault condition.